how hard can they really make 2D projections? Well, this is a good example of how hard they can make it, where we have a horizontal projection onto the ground, which is actually on an incline. How do we do it? It says a particle is projected horizontally from a point A on a 10-meter high tower. It's landing at the ground at B, which is inclined at an angle of theta degrees where tan theta is 0.2. Find the distance OB. All right, so with all of these questions, we do the same thing. Yeah, we consider the vertical and horizontal projection separately. So we consider this particle and we consider its vertical and horizontal separately. Because in the vertical, it is being subjected to gravity. Now I always take upwards to be positive, so gravity is minus 9.8. And horizontally, there is no acceleration. No acceleration literally means distance is speed times time. We go back to our basic formula that we learn in year 1. Now the vertical, because there is acceleration, not zero, we're going to use suvat. Now to find B, it's an interesting one. We're going to have to consider a couple of things. Let's just write down what we definitely know. U, what's the initial speed vertical? Well, we don't know, right? It's a horizontal projection, so U is 0. Now we're obviously interested in B. What do we know at B? Do we know its speed? Do we know its vertical speed? No, we don't. A is minus 9.8, and then there's T. So we've got to ask ourselves, are we more interested in the time here or the distance? Well, we'll figure that out once we consider the horizontal. Now, at B, from here, from the point of projection, do we know the horizontal distance? The answer is no. We'll just call it D. Is the speed, now we do know the horizontal speed is 8 times time. Now for that reason, I feel like I'm more interested in the time, but let's decide how this would even work. Now, usually what it is a horizontal, right? So let's just think about what we would have actually done if it was horizontal. If it was horizontal, you guys would have used this 10. And you would have said, over here, S is minus 10 because you're below the point of projection. But over here, we don't actually have that distance. So it's a little bit different. Now what we need then is we need to figure out the significance of the incline. And that's giving me vibes of its equation in Cartesian form. Because if it says tan theta is 0.2, what does that actually mean? So if we have an incline here, and they're telling us that tan theta is 0.2, which is 1/5, what does tan measure in a right-angled triangle? It tells us the opposite relative to the adjacent, meaning that this is 1, and the adjacent is 5. What does that tell us then? It tells us the gradient of the line. Opposite, the change in y over the change in x. And that's what tan theta tells us. It tells us that this line, y, is 1/5 x. Okay? Y is 1/5 x. So what we could do is we could find out the generic equation of this is a quadratic, right? In terms of t, do some simultaneous equations, work out what t is, and then we can work out where b is or what that distance is. Okay? Nice. So we've got a strategy now. So, what is y though? So when we say y equals 1/5 x, if I just kind of change this diagram, because the way they draw it in exams is a little bit strange compared to the way we observe it. So if we observe it like this, it's going to make our lives a bit easier. Okay? So we have this line is y equals 1/5 x. Now that y is relative to here. Okay, so this value here is y, and this is x. Now that horizontal x is the exact same as the particle. Okay, so relative to here, that x is the exact same. So we can say x equals 8t. Here we have it in terms of t. T is t. Now for y, it's a little bit different. Okay, so because it's relative to here, when I write this y, I'm going to put an asterisk because it's not actually the case. What links S, U, A, and T is? S equals UT plus half AT squared, right? But S is not just Y. Because it's relative to something. It's relative to O. Usually we just use this when we take its relative point to where we project from. So if we were taking everything relative to A, that would be fine. But because we have two lines and it's relative to O, it's not just UT plus half AT squared. You've got to think of this as Cartesian equations. If you had a quadratic and you had O and you had 10 and this negative quadratic, that's your y-intercept. So it's 10 plus the rest of it. Okay, so you're saying, okay, this is a negative quadratic, but relative to O, we have to add 10 and then we have that quadratic. Okay. Now U was just 0 anyway. So that's all right. Half of AT squared. Now A is minus 9.8. So half of that minus 4.9 T squared. Nice. Now that we have our X and Y in terms of T, we can sub into here and solve. So we have Y equals 8. X is 8t, a fifth of that. So 8 fifths t. Move that to the other side, 4.9 t squared plus a divided by 5 is 1.6. Oh, I can't be bothered to make a mistake. 1.6. And the plus 10 on the other side minus 10 is 0. Then we're going to do the quadratic formula. You must do this in the exam. So minus b plus or minus root b squared minus 4ac all over 2a. Then you've written that down, you can just go straight into your polynomial solver. 4.9, 1.6, minus 10. 1.27, so my first T1 is about 1.2746. Now I'm going to store that as a. And the other one is a negative value, which we know it can't be. We're interested in that. Okay, so I've stored that as a. We can now work out the x and y value. We're just going to sub it into both of these. Okay, so x, in fact, I can put equals for now. So menu 1, 8, a is 10.19, 6, 8, dot, dot, dot. I'm going to store that as b. Now to find y, you could sub in your a value here to get the y, or you could just divide it by 5. I'll show you guys that it just gives you the same thing by subbing into here. 10 minus 4.9 a squared, 2.03, which is about a third of this, a fifth of that, sorry. Store that as c. We're not done yet. Because what we just worked out is that this x is about 10, and this y is about 2. I asked you in the question to work out that distance, which means finally we need to do a cheeky Pythag, which is why I stored these values as b and c. So OB is going to be the root of this 10.19 dot, dot, dot squared, 2.03 dot, dot, dot squared. So we're going to get root of b squared plus c squared, about 10, you know. I think to two significant figures. So it gives you 10.398, etc. I literally just made up this question like 10 minutes ago, whenever I started recording. But that's it, guys. That is an incredibly tough question. I cannot lie. So you would have learned something, I'm sure. I'd really appreciate if you hit that like button, subscribe for more maths content. I'd recommend you save this video because of all the techniques we've learned. And if you're interested in my A-level maths courses, feel free to check out more details in the description. And if you want to join the LUN Gang community on Reddit to submit your own questions and get feedback from the community, then a link to that is in the description as well. I'll see you guys in the next video. Nice.